The homework for 4.4 is a lot because it's kind of important. Some of it's pretty easy and straightforward though. For solving exponential and logarithmic, oh, there's an N right there, exponential and logarithmic equations, keep in mind two things. If b to this power equals b to that power, then this equals that. Same thing for logs. Log base b of m equals log with the same base something else, then those two things must be equal. Those two quick little things are going to really help you. Another thing is, remember we're solving for the variable, right? If the variable is in the exponent, then you take the log with the same base of both sides of the equation. You'll see what this means. Same thing if the variable is inside the log. You rewrite as an exponential equation. Okay, so there's your rules. Here's a couple quick examples. If I have 2 to the x equals 32, then I have 2 to the x equals 2 to the 5, and x equals 5. Simple enough. What about 27 to the 2x equals 9? Well, 27 and 9 are both 3 to the power. So this is 3 cubed raised to another power. You multiply that powers equals 3 squared. That gives me 6x equals 2 and x equals 1/3. 9 to the x equals 1 over cube root of 3. Both of these are powers of 3. It's not pretty, but it is what it is. 9 is 3 squared raised to the x. And this power is 3. Now you see the 3's on the bottom, so it's a negative exponent. And it's in a radical, so 3 is raised to the first power and third root. Remember, the top is the power, the bottom's the root. Let me write that down. If you have x to a fraction, the top is the power, the bottom is the root. Keep that in mind. Okay, so 2x equals minus 1/3, and x equals minus 1/6. Let's try another one. What if we have e to the x plus 4 equals 1 over e to the 2x? Well, obviously both of those are powers of e. So this power equals the power on the e here. We see it's on the bottom, so it's negative 2x. And now we just solve for x. So I'm going to add 2x to both sides and subtract 4 and divide. Minus 4/3. So those are pretty straightforward. Let's try some more. I've got my cheat sheet. I know you can hear paper rustling here. What if we had 3 to the x equals 7? Now, in a case like this, 7 is not a perfect power of 3. So we just have to take the log of both sides. So we say log, and the base is 3, of 3x equals log base 3 of 7. Now, log base 3 of 3 to the power is just the power. Let me write that over here. Log base b of b to the x equals x, and if I have the base and it's raised to the power, well, the log is the exponent that makes, here, let me point. The log is the exponent that makes b equal x, and if I'm raising b to that power, then obviously I get the x back, okay? So let's remember these while we're working through these problems. So log base 3, what power do I raise 3 to make it equal 3 to the power? Obviously, it's the power. Log base 3 of 7 is just a number. I didn't elaborate too much about the change of base formula. If you needed to get the actual numerical value, which I'm not going to ask you to do, you would use a change of base. There's two different log keys on your calculator, a natural log and what's called a common log. It's log with log with no number that's understood to be 10. But you can use either one of those guys. You put the ln of the original on the bottom and the ln of the original question on the top, and you can plug that in your calculator and you can actually get a decimal representation of that answer. I don't need it because log base 3 of 7 is exact, so you can leave it that way. Let's try e to the x plus 4 equals 2. Well, 2 and e aren't related to each other, so because the x is in the exponent of the base e, we're going to take a log base e of both sides of the equation, and that's just ln. ln of e to the power equals the ln of 2. The ln of e to the power is just the power. ln of 2 is just a number. X equals the ln of 2, take away 4. Okay, now for something a little bit more complicated. If I have the ln of x plus another ln, and it equals an ln, remember the rule that the ln of this equals the ln of that, then this equals that. But on the left-hand side, I have to condense. Addition means multiplication. And that gives me x times x minus 2 equals 3. Distribute the x and move the 3 over. I get x squared minus 2x minus 3 equals 0. Factor. Factors of 3 that subtract to be negative 2. Solve each of these. I get 3 and negative 1. Now remember that you can't take the log of a negative or of 0. So we have to take both of these answers. For instance, the 3, I can take the ln of 3 and I can take the ln of 1. So 3 works, but the minus 1 plugged in here, I can't take the ln of a negative. So this one is out, and I get x equals 3 is my answer. Remember to always, always, always check your domain before you're done with your question. Let's try another one like this. We have log base 5 of x minus log base 5 of x minus 1 equals 2. We have to condense our logs first before we can do anything else. So you see that we have subtraction. That means the -1 goes on the bottom. Okay, now, because we have a log equals a number, over here we had an ln equals an ln. Here we have a log equals a number. So we have to rewrite this equation as an exponential. The base is 5. The log equals the exponent, so it's squared. And the answer to 5 squared is x over x minus 1. So we have this thing here equals 25. What you're going to do is multiply both sides by the denominator. You get x equals 25x minus 25. Get your x's together. There's 24 of them. Get them alone. It equals 25. And I get x equals 25 over 24. Check your answer. We're going to take this fraction. This fraction is bigger than 1. So it's positive, so it works here. Bigger than 1 minus 1, when I subtract, I still have a positive value. So I know that x does equal 25 over 24. Sometimes you get no solution. You always, and then always check your answers. Okay, a couple more solving equation problems here. We have e to the power equals 4. Now, to get the variable out of the exponent's place, we have to take that log. And the base is e, so we're going to be taking the ln of both sides. So the ln of e to the power equals the ln of 4. But the ln of e to the power is just the power. All right, so we're going to get the 3x alone by subtracting the 1. And then solve for x by dividing. There you go. One more that should remind you of something that we did earlier. Notice that these e's have different exponents. And notice also that this exponent times this e to the x times itself is e to the 2x. That means this guy is quadratic in form. It's e to the x times e to the x. Factors of 3 that subtract to be -2. Set each of these things equal to 0. We get e to the x equals 3 and e to the x equals -1. Now wait a second. E itself is 2.7 something. There is no exponent that I can raise that to make it equal a negative number. So this guy is out. And we get e to the x equals 3. Now, how do we get x down to the line and solve for it? We take the ln of both sides. And we get x equals ln of 3. All right, so that should be enough juice in your tank for you to get going on the homework. I just want to show you a couple of things here. If I say evaluate without a calculator, something like 2 ln of e to the 7 minus 3 ln of e to the 1. You have to recognize that the ln of e to the power is just a number. It's just the power. So this is 2 times 7 minus 3 times 1, and you get 11. Also, try log base 5 of 75 minus log base 5 of 3. Now, 75 is not 5 to the power, and 3 is not 5 to the power. So how in the world are you going to evaluate this and get an exact answer without a calculator? you will use the properties of logarithms. They're both base 5, so we can condense these using division. Log base 5 of 75 divided by 3 is log base 5 of 25. And log base 5, remember this is asking the question, 5 to the what equals 25, and we get that this thing just equals 2.